Thank you. He was my colleague, so I will take his 5 minutes for my presentation, if that's okay. I can see it here. First of all, what is a rejuvenator, right? Maybe I'm working with it every day, but not all of you do so. So I'll quickly go over why do we need a rejuvenator at all. So first of all, when we mill the old asphalt, that's mainly because it has aged. There are some potholes, the binder is getting stiffer, so we need to mill it and we bring it to the asphalt plant. We can reprocess it, we can screen it, we can crush it, and so on. Of course, we have our virgin materials, and by combining these two in a certain mix design recipe, we can produce a new asphalt mixture. Well, if you add a little bit of the reclaimed asphalt, let's say 10–15%, you don't really have to care about anything. You just use your mix design recipe as it is. If you add a little bit more, let's say up to 30%, you already need to start thinking about how to compensate for your aged asphalt binder. So in this case, you might be well off by adding a softer binder grade. So if you normally use 50–70, maybe by adding 30% reclaimed asphalt, you should switch to 70–100. But if you go higher than that, you really don't have the capacity to add the softer binder grade anymore. First of all, it's not going to be soft enough, because in your region, you probably cannot get a very soft binder. And second of all, your mix design recipe will simply not allow to put as much binder as you need in there. So in this case, we can use rejuvenators. And obviously, we want to pave and use the mixture as a normal road as we would do normally. So a rejuvenator is a sort of oil. It's not really rejuvenating it, rejuvenating the binder chemically. Otherwise, we would be using it on our faces and be forever young. But it does provide us the mechanical performance of the bitumen that we want for another service period of the pavement. So we want some softening effect. We want to regain the elasticity of the binder and so on. The types of rejuvenators, they can be different oils, starting from, someone mentioned here, the waste engine oil. It could be a refined oil. It could be vegetable oil or pine oil or whatever. There's no real definition at the moment. Well, now the problem. If we have an aggregate and we have it covered with the binder film, and we apply a rejuvenator on it, right? Now the rejuvenator is covering the binder film from outside. So in order to blend together, it has to first diffuse into the old binder film. And that's not really so simple, because the diffusion and the mixing process will depend on the aging state of the old binder. It will depend on the rejuvenator. It will depend on the temperature that we're using in the mixing plant. It will depend on the time of the exposure to temperature. So there are all these factors that affect the result. And the result will, in most cases, be blending or this binder activation somewhere between 0 and 100%. We probably will not be able to activate 100% of the old reclaimed asphalt binder. This is an image we took in another project. We replaced a portion of the filler with a tracer, with an titanium oxide. And you can see that the tracer is everywhere except on a very thin binder film around the wrap aggregate. This means that basically we are not reaching this binder. Although it's there, in the mix design calculation, we would consider it as binder. Actually, it's more likely a part of the rock instead of being part of the binder. So obviously, as a mix designer, as an asphalt producer, we want to maximize the portion of the binder that we are getting from the old wrap, because that's the most expensive portion. It's the portion that provides elasticity, it resists cracking, and so on. So we want to maximize this part. So the question is how to do it the most efficient way. Of course, there are different rejuvenators, different plant technologies, but one thing that we have to decide is how to add the rejuvenator. So the normal way, or the traditional way that it's done, is usually after heating of the reclaimed asphalt, in the mixing or the pug mill, the mixing drum, there's an additive dosage system. So we can add the rejuvenator there. Sometimes it's also added to a virgin bitumen. This would be kind of creating your own soft binder grade. But who is to say that we cannot add it earlier, right? The longer the rejuvenator is in contact with the binder, the more diffusion we will have, the more binder we can potentially activate. So we could add it to the old asphalt before it's being heated, so the cold reclaimed asphalt. We could add it even earlier when we're processing the material, and even maybe during the milling operation. We actually went ahead and we counted that there are potentially, theoretically, 10 different locations where we could add the rejuvenator. So you see the blue ones are upstream of the recycled dryer drum, and the kind of yellow ones are downstream of the dryer drum, and the purple ones are in the virgin bitumen line. Okay? In this example, somewhere where number 3 is, those are the cold storage bins, then the material goes up in the tower, it's being heated there in the hot mixer, in the hot dryer, and down in the tower there's the mixer. What we want from these different options is not only the maximizing of binder activation. We, of course, want it to be environmentally safe, so we have to check what are the conditions that we can make it safe. And some of the options are disqualified right away because, for example, we don't want the rejuvenator to be leaking into the ground, so we cannot really add it in the stockpile. Next, we want to be sure that it is technically possible to add the rejuvenator somewhere in the plant to control the dosage and integrate in the plant system. And finally, we, of course, want the mixture to have the quality, the rejuvenator to be precisely dosed, the resultant mixture to have its properties as we designed, and so on. So at the end, based on this kind of theoretical calculation, we saw that there are 3 different options. 2 of them are quite similar, so we decided to focus on 2 of them, and we went ahead actually in asphalt plant, and we tried these 2 different options of rejuvenator addition. So one of them is adding the rejuvenator after the reclaimed asphalt binder has been reclaimed asphalt has been heated in the mixer. Right, that's somewhere here. And the other option is to add the rejuvenator to the cold asphalt right after it's leaving the cold storage bins on the belt. So here we are able to control the dosage based on the volume of the material. Okay, so that's here. Now, we have 2 additional locations, but I actually have five different places to take samples. First of all, I have just a wrap sample. We took it before adding the rejuvenator. Next one, right after addition of the rejuvenator to the cold asphalt. And you can see in the letters, it means we sprayed the rejuvenator, then we, on a cold reclaimed asphalt, and we sampled the mixture cold. Next, this same sample went through the heating drum, so we sampled it hot. Next, we sampled a reclaimed asphalt that was heated without any rejuvenator. And finally, we had a sample where the rejuvenator was applied hot, and it was sampled hot. I know it's a little bit, a lot of information to take on, so if you feel like sleeping for a while, that's fine with me. I'll wake you up in the conclusion section. That's going to be very easy, I promise. So now I have my 5 different addition spots, and I wanted to have 3% of rejuvenator dosage at each of these spots. Unfortunately, since this is a real life, this is a real production process, the reclaimed asphalt binder content varied. So although my dosing was the same for each of these cases, since the reclaimed asphalt binder content varied, then obviously my proportion of the rejuvenator also varied a little bit. So instead of 3%, I got somewhere between 2.6 and 3.1. That would be fine for actual production process, but since this is a research study, I had to somehow take this into account. So what I did is I took my samples that were sampled hot, the one without any rejuvenator, and the one where I added the rejuvenator in the mixer, and these are kind of the baseline. So I know that these are the same. The only difference is that the rejuvenator content is different. So for one of them is 0, for the other is 3.11%. And if I connect them with the line, so I can say that if the only difference between any of my samples would be the rejuvenator dosage, the samples would align on this trend line somewhere. If there is some other effect, like aging in the drum, like losing of some rejuvenator, whatever, the result would not be on this line. As we can see, the penetration difference between this line and the different samples is actually very small. It's about 1 to 2 decimillimeters. That's nothing, considering that we did all these steps, producing, extraction, measuring, and these things. So I can say that based on penetration, the addition spot didn't make a difference. Next, softening point, and basically the same idea. Again, the results are almost on the trend line. Next, we did use the dynamic shear Rheometer, which to build a master curve, which is basically the stiffness and elasticity ratio at different frequencies of the reclaimed asphalt binder. And of course, we can see, the stiffer the material, the higher the master curve would be in this graph. And of course, we see that the reclaimed asphalt binder, where we don't have any rejuvenator, the lines are higher up. When we have added the rejuvenator, they are lowering, but we again see that they are lowering to the same extent whether we added the rejuvenator to hot or to the cold binder or wrap. And finally, Professor Zovka already explained the Fourier transform infrared spectroscopy. This is what we use to evaluate chemically the differences. And these are the two functional groups, as he explained, that represent aging of the binder. So sulfoxide group and carbonyl group are the ones that increase. The area below the curve increases when the material ages. So, as I said, we didn't see any reduction of these areas. That's because we cannot rejuvenate, really, we cannot restore the chemical structure of the aged binder. But what we wanted to see is whether, based on our addition spot, the area increases for one or the other case. So to do that, we can plot the area in a chart as an index. And if we focus only on the green line, this is the combination of these two areas. We see that first of all, the second kind of group, the spray CH, which means that we sprayed the rejuvenator on a cold asphalt and sampled hot, is basically the same, has the same index as the mixer HH, where the rejuvenator was sprayed or added in the mixer and sampled hot. So there has not been additional aging due to addition of the rejuvenator before the drum. Okay, so now the conclusion. And it's very simple. The rejuvenator addition point did not make any difference with respect to the binder properties. So regardless if we added it to cold wrap or to the hot wrap, the effects were the same on the binder. It took me quite a lot of effort to find this out, right? We did produce in an asphalt plant tons of mixes, tons of asphalt mixture. We did all this extraction work and testing. But actually, the conclusion that we don't see any result or any difference is a good one, because we know that it's not worth to add the rejuvenator before heating of the wrap. Whether it's better, I cannot answer at the moment because we haven't done any testing on the mixture. So as I said, when we extract the binder, we blend all the materials together. So in this case, we kind of artificially assume 100% blending, which is not what happens in the real world. In the real world, there is probably a little bit less blending, and that we have to find out by testing asphalt mixture. That is what we intend to do. We have already gathered samples, and we will perform the testing on asphalt mixtures. In addition to that, during the production, we measure the emissions, so that concerns the first part of the evaluation, where I said it has to be environmentally safe, both to the crew and to the environment, with respect to pollution. So, thank you very much. With that, I will conclude.
Thank you, Martins, for your presentation. So any questions to Martins? No? So, thank you. Our next speaker is Priit Vilva from Estonia, and he's going to talk about trial concrete